Good evening. Today's going to mark day 12 of FoP. We're going to continue on the lesson that we left off on. I believe it's going to be lesson 12, searching, sorting, and recursion. We're about halfway through it. We're going to finish sorting, and then it'll go into recursion, and then we'll start, but not finish lesson 13, which is going to be regex, regular expressions, and ASCII characters. We'll only barely touch it before we have to go into the weekend. Before we start, are there any questions on everything that has been covered up to this point? Um, Before we move on forward, especially because once we get into recursion, we tend to lose some people and on understanding it. So before we even get there, does everyone understand up to this point? Big O notation, the different time complexities, and the algorithm we've covered. We're currently on sorting, and I asked this for just people that have either been absent or haven't been able to keep up with the videos. We can do a small recap for about 10 minutes prior to starting. That's no issue as long as it means that everybody is on the same page. So I'll open the floor for any questions that anyone might have. And don't hesitate to ask. You might not be the only person that has these questions. So go right ahead. No questions at all. Nobody. You guys are good. And if you are, it's okay. That's where we would like to be at. Um, I just want to make sure I give the opportunity now and allocate that time for anybody that it might be struggling or feel they just need for me to touch up on something once again if it just didn't click as well the first time. So do not hesitate. Thank you for those that stayed here after class yesterday. I do appreciate that. Um, I will allocate the time for you if you want it afterwards. So do not hesitate to ask. But without further ado, we're going to pick up from where we left off. I do apologize if you hear my son in the background. He's excited watching Blue's Clues. So let's go ahead and share the screen. We ended up working through bubblesort.py, and we read through the example before cutting off the class yesterday. Today we'll start and pick up from where we left off. It's going to be something very similar to what we did yesterday evening. It's just going to be another bubble sort problem to help you solidify what you've learned. So we will take some time for that. Time is currently 5:36. We'll take 15 minutes to try it out, and then we'll talk through the problem. So go ahead and, as a matter of fact, actually, um, before we cut out, I think let's try to do some group work. So I'll break you off into groups of two. That way you guys can help each other out. We have the time. We are fairly ahead of schedule, so we can uh spend a little bit more time with some individual teaching and some group work and discussing. So well, I think moving forward from now until the end of FOP, we'll try to put some more emphasis on some group work. That way we can get some more one-on-one or one-on-two, um, because we have the time available to us. So let's do that instead. Okay, so that went pretty well. We're just going to cover real quick the bubble sort count before continuing. Um, Essentially, the bubble sort count was the exact same thing as the bubble sort uh, assignment, except we added two different variables now, uh, called comparisons and exchanges. All right, the only thing different here was we just tracked every time that we compared two different values and when we actually exchange one of them. Uh, So nothing too different here from yesterday's code. We're still just doing the exact same thing. Only difference is right before we actually go into the coding of comparing, right? Our comparators are less than, greater than, are double equal signs. We're going to increase the count of comparisons by one. Therefore, tracking that we've already compared one item, and it will actually go ahead and compare. Or I mean, you can also do it right after all this outside of the for loop. It doesn't really matter where, as long as it's within the for loop that initiates at line 7. We will increase our comparisons count, and then the exchange count would just be within the if statement after line 9. So nothing much here to really do. I will say, right? I mean, it's not wrong for you guys, but try to avoid copying code as much as possible at this state. If you're getting it, that's great. For those of you that don't, I mean, eventually, if we already have the code, right? In the future, we don't want to actually repeat ourselves, so we use our drive method, right? We don't repeat yourself. Just if we got the code, we reuse it, and that's obviously the right mentality. Absolutely, nothing against y'all, but try to just manually code as much as possible, so you get that muscle memory. So it really sets, that it clicks whenever you're doing anything, any of the coding stuff. It really just helps, just that muscle memory. It helps solidify the knowledge. If you want to not do that, that's fine. Just my own personal advice. That's just how I learned. So just a slight recommendation. But yeah, so that's gonna cover bubble sort. Nothing major from yesterday. The exact same thing, only just two different values we're going to be keeping track of. And now we're going to continue with the lesson. So we did bubble sort count, and the next topic is going to be recursion. All right, so recursion. We know that functions can call other functions, right? But a function can also call itself, right? And that is known as recursion, right? You can almost think of it very similar to like Inception, right? A dream within a dream within a dream and whatnot. And it's kind of like what recursion does. It turns out that anything you can do with loops, you can also do with recursion, right? All recursive functions are comprised of two elements: a base case, where the recursive function stops. Sometimes you can have more than one base case, and the recursive call, where the function calls itself, right? If your recursion doesn't work, or you're getting an issue, right? You're getting some form of an overflow. It's probably because you didn't set a proper base case. And that's what's going to give you that stack overflow error. And yes, that is where stack overflow gets its name from, right? So if you get an overflow error, it's probably because you didn't set a proper base case, or you probably put in the wrong line. I personally struggle with recursion sometimes too. I get very twisted in my own head. All right, but we'll go into very simple examples to try to solidify it on everyone's minds. So what two elements does a recursive function have again? What was that? Anybody?
Base case and the recursion
And
call.
the recursive call. Correct. All right, awesome. So notice how the recursive call always contains a smaller version of the original problem. And we're going to see that here, right? We have a little code snippet right here, factorial, where it's going to take in a number, and here's going to be the base case. On line 2, it's going to be our if statement, and we're going to see if the number is equal to 0. And once that number is actually 0, we're going to return 1. And if it does not equal 0, then we're going to go into this else statement, where it's going to say return num times factorial num minus 1. And on line 5, we essentially call the method within, or the function within the function, right? This is the same function that we're currently declaring. And this is the recursive call. This is where people tend to get confused. the inception within this function right here. And what's factorial, right? We want to get the if we were to multiply it to itself, and we want to get the base case going to be 0, then we're going to keep doing this until that number reaches the condition, right? So once it gets to line 5, it's going to call this function, and this first time it was called, it's going to be put on pause, right? Because it never finished. Once it gets to line 5, it's going to call the function within itself, and it's going to open up a whole other stack. And we can kind of see a little example of that. It's going to look something like this. This is going to be your initial function call, factorial. It takes in num. Within this function, whenever you call it, this function it's not going to be able to finish because it's going to call itself, right? 1, let's say it's 5, right? It's going to be 5. And we said that the base case is going to be if number is equal to 0. Well, when it goes into the function, obviously the number isn't 0, so it won't return yet, and it's going to call itself. But this time, when we call itself, we're passing in the same number, but now we're reducing it by 1. And it's going to, how can I copy? And it's going to call itself, right? So within that function, the initial function is going to call itself, but with a different number. Now this one is factorial num, but num is going to equal to 4. And this function never finished, right? It hasn't been closed out yet because now our code went inside another function. So this one is still open, but now we're within this one. And factorial with number 4 is going to do the same thing. It's going to come into line 1. It's going to check, is my number equal 0? It is not. So I'm not even going to go into line 3. I go to the else statement, and now I'm going to return num times, and it calls itself again, right? So this line won't even finish yet. It's going to call itself again. And within this function, guess what it's doing? Correct. You're right. It's going to call itself again, right? It's going to dive into another factorial call. But within that factorial call, we lowered the num again. So now num is equal to 3. Give me a second. My son just walked in. Nicholas. Go on. I'm sorry for that. My son just likes to say hello. Yeah, so within this function call, it calls itself again, but now we lower that argument to 3. So it does the exact same thing. Inside of this, it runs again. It's checking if number is equal to 0. It's not. And it's going to keep doing this, right? It's going to keep doing this little dance that we have here until it reaches a certain condition. So it's going to be 2. It's going to be 1. And this one could be 0. After it goes in the third time, it's going to check, hey, am I equal to 0? No. So I'm going to call myself again. It goes into the next function call. And all these are still pending. Nothing has returned yet, right? We're just diving deeper and deeper into this hole, this recursive hole, as we call upon ourselves. And then it's going to finally get into the last call. And now finally, within this function right here, factorial with num of 1, it calls itself for the last time, right? But this time we lower that number once again, and it finally reached 0. And finally, within the 6th stack, right? it finally reached that base case. So now it's going to return, right? It's going to return. It closes up, and that is going to return what? Well, on this stack, num is equal to 0. So num, so 0 times 0 is going to be that was what you call it? It got to the first line is equal to 0, so it returns 1, right? So from this function, what came back from it? 1 came back. Although we passed in num, which is equal to 0 within it, 1 came back. So that's what we set up as the base case. So now num returns into this function call, right? So this is going to be whatever num was, which is 1, right, times what the num was prior to that. And what was it prior? It was 1. So 1 times 1 is going to be 2, and it's going to keep doing that and multiply itself until it reaches its final call, right? All the way back to the front. From here, it goes into 1 times 1 is 2, times 2, because that's what this one was, is 4, times 3 is 12. It's going to keep doing that until it reaches back to the base case, right? And that's how the recursion works. It's going to keep calling upon itself until it reaches that base case that you had set up. And as that returns, it finishes every single function that you've called, right? So to describe it, this returns 1, right? And what did we initially pass in here? Well, we passed it num is 1. So when it came in here, this was 1. That recursion call returned 1. So this is going to return 2, right? So 1 times 1 is 2. So we're now within this function call, which is 2 itself. This comes back, it passes it 2, so num times 2 is 4. So therefore, this function call is going to return 4, right? This function call ended. It comes inside, it comes back to this one. We pass in 3 into this one, right? So num is equal to 3, but the function call finally closed out, which is 4. So 4 times 3 is going to be 12. And it's going to keep doing that, right? As it closes out all your function calls that it opened up earlier. 12 times 4, 12 times 4, 36, 48, I think. And then this will close out. And it's going to keep doing that, right? Close it all the way until it gets back here. The first time it calls it was 5. All those extra stacks of function calls finally come back and return with 48. 48 times 5, I don't know what that is. If anyone wants to give me the math for that. Let's see if I can calculator. 48 times 5. 240. 240. So in the end, the very first function call we opened up should return 240. And let's see that. I'm going to open up a new file. We'll call this factorial.py. Define factorial. It's going to take in num. If num is equal to 0, return 1. Else, return num times itself. But now in here, we're doing -1. Or I'm sorry, -1. So let's go ahead and call it. We can print factorial. We'll pass it 5. Let's see if my math is correct or I'm just dumb. Where are we? An FoP. But where's factorial.py at?
Lesson 12.
Jesus Christ, man. CD less than 12. CD bubble. Python. What? Oh, I didn't save it. My bad. Save. It should be in here. Do not save. Save. I know where I'm at. God dang it. Hmm. 120. I'm done, man. My math was wrong. Anyways, let's actually see that. Can we print it? Where would I print it? Mm, I wonder if I can print this right here. Nope. Okay, it's returning. Oh, because I returned 5. Why is it return 5? If num is equal to 0, return 5. So it goes in here. It calls upon itself until it reaches a certain number. It gets down to 0, returns 1 times what 1 was is 2 times 3, 6. Did I do my math wrong? Anyone want to help me out here? Let's see. So it gets to in here, returns 1.
Can you scroll down a little bit?
Oh,
I mean,
factorial 1 would be 1 because it's 1 times 1, right?
yeah.
So it'd be
Yeah.
no, that's be
Yeah,
1
you
times
kept
0.
Yeah,
yeah,
he
that'd be
kept
1.
saying 1 times 1 equals 2. That's where you went
Dude,
wrong.
oh my God. I'm telling you, man, math is horrible. All right, so
So it
1
would
times
stop at 120.
2. 2 times 4 is 8. 8
No,
times
no,
4.
that'd be the factorial num1 would be 1. So it would be 1, 1, 2, 4.
1, 1, 2, 4. I see what you mean.
Or no, 2, 6 it'd be because it'd be 2 times 3.
Because it gets to this one, right? This one is going to be 0, but it returns 1 back to this.
Right.
This one was passed in here, so 1 times 1
You won.
is 1. 2 was passed in here, so this returns 1. So this gets 2. Then it comes
Yep.
back
6.
6 times 4 is 6, 12, 18, 24, and then times 5. Dude, my math was way off. I'm telling you, man. I'm telling you, I'm not the brightest, right? All right, and if I can do it, you guys can too. All right. All right, my math was wrong, but I'm assuming if the fact that you guys are able to see this, you understand the concept, right? It's returning upon itself. It's calling the function within itself until it gets deeper on all these stacks. These calls stay open, right? It makes a function call, but they never return because they're just going deeper and deeper, calling upon itself until it reaches a base case. And then once it reaches that case, it comes back up, right? This closes out, it returns a certain item with it, and it pretty much just does the function for you until it comes back and returns that to you, right? But do you guys understand the main concept pretty much of how it's calling upon itself and it's not closing until it reaches that base case? It keeps calling itself until it reaches a base case that you had set. And then once it reaches that case, it's able to close out those functions, right? Because it finally reached that base case. and then it finally actually does the arithmetic that was written here on line 5, right? Because once it gets to the top setting or the lowest setting that matches our base case, it returns 1. So whenever it calls this function returned 1, and we had said whatever returns from here, I want to multiply it to what num is within this function, and it keeps doing that. It's just like a box within a box within a box within a box. All right. I'm glad that you guys can at least understand the concept, even though my math was absolute fucking freaking garbage. I'm sorry for cussing. Absolute garbage. You guys understand that concept, right?
That's
I'm
the
gonna
first
be
time I've ever
straight up.
understood
I
it.
understand the theory, but when it comes to coding it, oh, that's a different problem.
Yeah.
But yes, I understand the theory of it, but it's some problems where it don't make no sense.
No, I understand that it's difficult. You don't see many people often use it. Just casually. It's not something that most people just casually use. This is why, because it can be very confusing. But yeah, so I'm glad you guys at least understand the main concept, and we'll be working on small, easy examples like this one for you guys to be able to try out and really just understand the concept. And that's all we really expect from you guys. To be completely transparent with you, you'll cover it in the same manner that we're covering it now in the full stack immersive program, but you're not really gonna use it, right? It's covered to give you exposure to it for you to understand what it is, how to do it. You'll have assignments for it, but it won't be more than 2 or 3 assignments like tops, because it's not something that you're really gonna use in the full stack immersive program, right? Even if you don't understand recursion today or tomorrow or the next week, it's not really going to affect your progress with the full stack immersive program, because it's not really applicable to actually just making your web pages, right? Unless what you're working with need certain algorithms like this, but most of the data that you guys have been working with won't really require any of this. It's almost going to be like what's the word I'm looking for? It's not even going to be relevant to the projects you'll really be working with. We teach it, we talk about it for you to understand it. And if you want to get better at it because you want to work with this type of data, or you have to use complex algorithms like this, then you can, but it's not really necessary, if that makes sense, right? So definitely do understand it, get some exposure to it. Try to understand the main concept, but don't get too wrapped up around this. Okay. Recursion example. So a better version of it. What the? Oh, not much of an improvement, but it just obviously if it doesn't equal 0, you don't have to put else, right? I'm sure you guys already caught up to that. You don't have to do the if else statements, because if it doesn't meet this condition on line 2, it's gonna run line 5 regardless if you were to just put it like this on line 4. But yeah. So notice how the recursive call always contains a smaller version of the original problem. That's ultimately how it reaches its base case and exits the function. The function doesn't call itself indefinitely, leading to a stack overflow. Yes, that's where the name for the website comes from. Oh, okay. I didn't see that. Remember, you can use an implicit return and omit the else condition. It's honestly the exact same thing. But just know that you can do this, right? It's pretty self-explanatory. If it doesn't even meet the condition on line 2, obviously it's just going to skip it and just go to line 4. So just be aware you can do that. And this could be your first attempt to do it. So here's going to be recursion intro.py. I'm going to break you up into groups again, allow you guys to do that group work, and then float around to see if I can help in any shape, way, or form. All right, we're closing on the breakout rooms. I think for the most part, every single team did pretty solid on the recursion calls. So we'll wait for everybody to come in. Share my screen.
I think the difficult part for me is just how to write the last step. Like how to make sure it's
Yeah.
a string, you know.
Yeah, it is very confusing. It takes its own type of skill, if I'm being honest. Share screen. All right, so I think that's everybody in here. We just finished recursion intro.py. We're going to walk through it for the sake of documenting it and letting people see some kind of a example. So we were giving 3 functions to create within this one assignment. The first one was write a function called countdown, right? That's going to take a positive integer parameter and it's going to return a string that counts down from that number to 1. If we were to take 5, we would just start counting from 5, 4, 3, 2, 1. And that's kind of what we did here. On the countdown, the initial number here will end up being 5. We set up our base case here to check when they actually reach a certain number so we can stop calling upon itself. And then in our else statement on line 5, we immediately just assign it here and we start creating a string. If you look at it, we convert our number 5 into a string. We're going to add a space to give it a little spacing that was demonstrated here. And then to the right of it, we're going to add another string onto it. And it's going to be whatever comes back from this function, right? But this time, the new parameter, we're going to change it. We're going to subtract 1 by it. So now it's going to become 4. It's going to call upon itself. It goes through the same loop that we just covered. It's going to add 4 space, and then what's going to be to the right of 4, it's going to be the function, whatever comes back from that function. It's going to do that. It's essentially creating a for loop if you think about it, where it's just going to loop over and over and over again until it reaches a condition. The condition being once it becomes 1, right? And that's honestly the best way of trying to think about recursion. It's honestly just a loop, and it's going to keep doing something until it reaches it, right? Almost like a while loop. While this is this, do this. I think the hard part is honestly just trying to comprehend the fact that it's calling itself, right? And then if we run this, we should be able to get recursion. Yep. So we put in 5, it prints out 5, and then it has a space, takes in 4, and so on and so forth. And we did something very similar on the next couple lines for count up. This time we had to do the exact opposite. Take a positive integer and then return the string that counts up from 1 to that number. We set up the same base condition. This time the big difference, honestly, is we just did a flippy flip, right? Instead of adding stuff to the right, we're just gonna be adding it to the left. There was no big secret to how to do this. Honestly, you essentially just flipped of how you're formatting your strings, right? And then we have the third one, which is somewhat different than the other two. Where this time we're doing some math. We took in a number and we wanted to add all the numbers that came before it and return that sum. Essentially set up a very similar case. We check once it actually reaches 1, and then we will grab the number that starts off, like for this instance was 5, and we will add whatever comes back from the next function, and it kept calling itself. Starts at 5, it adds what comes back from the second function, which will be 4, then 3, and then 2, and then 1. therefore creating this loop that we were trying to achieve, giving us the answer that we now got. Very simple problems. Hopefully, this gives you a better understanding of how recursion works. I know it can get very confusing. It takes practice. This is the picture of recursion, right? It's essentially Inception, but we'll keep moving forward. Actually, it's 7:21. We haven't taken a break since we started, so let's take a 10-minute break. Let's come back at 7:31. All right, let's come back. We're actually gonna go straight into another, what you call it, assignment. Let me go to share my screen. All right, so continue on from recursion, the call stack. All right, so the call stack is pretty much what I try to draw out for you guys. This is what a stack kind of looks like, or a way to picture it, like a stack of pancakes. That's what we mean when we say call stack. So when running a recursive function, multiple copies of the function will be active at once, but only the most recent one will be executing. The others are paused while waiting for a result. So the initial call, the first one that starts it, is going to be at the very bottom. It takes the least priority once we start calling a function within itself. Essentially, the first function called is going to be put on pause, right? Because it dives deeper within itself, calling itself in its code, stacking up all these function calls until it reaches a base case, pausing everything within itself until it reaches that final stack, that base case, or whatever you set it, whether it be like 0 or 1, whatever condition you were trying to meet, and then it works backwards, right? From the top all the way to the bottom, slowly, right? So usually the first call is also the last call to be taken care of, because they close in the opposite direction, right? You don't just eat the bottom pancake if you got 6-7 stacks of pancakes. You don't just start chipping away the bottom one. You start from the top typically, right? And that's kind of how it works. That's the call stack. Python tutor walkthrough. I'm not sure too much about this. We'll talk about this some other time. Don't worry about this part. We're going to go straight into the recursive mult.py. I will break up into groups for this one as well and attempt it before we talk about it. All right, welcome back. We're gonna continue from where we left off. We took a break for the recursive mult.py. We had to write a recursive function named multiply that takes two positive integers as parameters and returns the product of those two numbers, the result from multiplying them together. You should not use multiplication. You should find the result by using addition to get your thinking on the right track. And the code cannot contain any loops. If you honestly really think about it, recursion is a loop in itself, right? It's just diving deeper, constantly calling itself. But yeah, so we started here. We set our base condition. If b is equal to 1, we're going to return a. And then what we did was we were going to manipulate b, right? And we came to this conclusion by looking at the code on the right side from 3 to 7 of how it actually works. If we're going to multiply, what you call it, by this number, then you can see here of how essentially it's going to work. And that's kind of what we just replicated here, just changing it over and over again until we reach 1. We're lowering it and then just bring it all back, and it adds it all together, giving you the result that you're looking for. And I was asked during the breakout rooms, what would be the, why would we do this? Why wouldn't we why don't we just add loops in here, or why would we choose recursion over a for loop? And the simple answer is honestly, you really wouldn't. What is the pros and cons of recursion and or just using a for loop to do the same function? Well, they both have their own pros and cons. Recursion looks a little bit more elegant. It's somewhat neater. And if you can read it, it looks a little bit more professional. But in comparison to a for loop where you'd be adding all this other arithmetic and code in there, the recursion looks better. But overall, there's no real advantage to using recursion. When it comes to time and space complexity, for loops tend to have a much better space complexity due to the fact that you're not making multiple call stacks and having things on pause. So you have that pro with for loops, and when it comes to time complexity for recursion, it also just varies as well on what you're doing. It can range from O of n to O of n squared or log of n, depending on the arithmetic. But it's not really going to be O of 1, right? Or technically recursion, you're calling it upon itself to do something. So you're doing something usually dependent on a base condition, therefore a certain amount, or until you reach something. Typically being O of n, right? Very similar to how the for loops work. So it's not like it's going to be instant or anything, or it's faster than the other one. So there's not really any pros and cons here. We did ask you to not use any loops, just so you can kind of understand the main concept of the recursion and what it's asking of you. But besides that, no true benefit. As mentioned before, you probably won't see this much moving forward into the full stack immersive program. They'll get too wrapped up in recursive. You are going to cover it. There are going to be some assignments. I didn't have to use it when going through. Half the time, you're not going to have to use it for any of your full stack applications. It's not really needed. It's nice to know, but don't dwell too much on it if you feel like you're struggling with it. It's not a big deal. So different ways to write a recursive function. It's often the case that a recursive function will need extra, right, parameters, such as a counter to keep track of which subproblem the function is currently working on. Here's an example of a default parameter. One thing that I do want to ensure you guys are tracking this, when setting up your recursive calls, and we're just making the function in general, know that if you are to declare a variable in here, for example, instead of line 2 being where it's at and it was a little bit lower, and you declared a variable called result or total or counter or whatever, and you started at 0 and whatever, and then you call the function call later on in that same function, if you don't change that counter, well, guess what that counter is going to be called as every time you use that function? It's going to start off as how you set it, at 0 or at blank, or empty string, whatever you initially declare, because you're never changing it. And that's a very common and easy mistake that people make when they first start making or working with recursion, is they're wondering why it's not working and their concept not working. If you don't actively change your values or your variables, they're not going to change, right? So just keep that in mind. Up to this point, are there any questions before we move on to the final 2 problems of the night? Okay, we're about to finish this lesson. The last thing we have is going to be a list max.py and is decreasing.py. We're going to go back into our breakout rooms. We're going to do these, and then we'll finish out the night by reviewing it together.